So first I will take few computers for creating a local area network. So I will click the N device at your bottom corner left. Here are the devices. I will take computers. I have taken two computers. For taking computers I just have drag and drop. I will take two laptops. So I have taken two computers and two laptops. You can see my cursor have selected the laptop. So I want to release the cursor. For releasing the cursor I have to press the escape button from the keyboard. Yes, you can see my cursor have released the tool. So when we use any particular tool using our cursor hold that particular tool unless you release that. If you need to release that tool from the cursor, from the selected position, if you want to release that particular tool, you have to use the escape button from the keyboard. Now I will take switch. So from these devices I will click this switch option. So after clicking to this switch option, you can see this many numbers of model are appeared. So 2950-24, 2950T, 2960 generic. This many numbers of switch models are available. I will choose this particular model 2950-24. You can try some other model. So now I will connect all those computers with this switch. For doing so I will use a cable. So I have to click here on this connection tab. You can check it out. This is connection tab. So after I click this connection tab, this many numbers of cable had appeared in front of me. You can see among this many cables I will require to use straight cable. So you can see it is written copper straight through. So I will use this particular cable. Other cables will not work. For connecting switch to computer or switch to laptop, I have to use this particular cable. It is required to use copper straight cable because we have discussed in the theory portion that to connect separate kind of device we have to use straight copper wire, and to connect same kind of devices we have to use cross copper wire. As because switches and computer laptops both are under separate type of devices. Computer and laptops, those were N devices, and switch fall under separate devices. So to connect those devices we need to use straight copper wire. So now I will select this particular wire, particular cable. So now I have selected the cable. So now I am going to connect the switch with these computers and laptop. So first I have selected the switch port. There I can see 24 ports are available, starting from first Ethernet 01 to first Ethernet 024. There are 24 ports. So among those 24 ports I may use any port. So let me maintain a proper sequence. I will use the first port. So this is a 24 port switch. So I am using a 24 port switch, and I will plug the Ethernet cable one end at the first Ethernet 01, and other end I will connect it to the network card, or the you can say LAN card of the computer of PC 0. So you can see this is the network card, or you can say LAN card, or you can say NIC card. So only a single card are available in each PC. You can see only one first Ethernet port. That means only one LAN port are available in each PC or laptop. So I will use this particular port. Don't wrongly connect the Ethernet cable to RS-232. Then if you do that, the function will not work, because this particular port is used in different purpose, not for creating a LAN setup. For creating a LAN setup you have to connect the Ethernet cable at the LAN port of a computer. So this is the LAN port, first Ethernet 0. So you can see the color of the computer LAN port is green, but the color of switch LAN port is orange. Why it is so? Because switch contain the MAC table, and MAC table records the MAC address of the corresponding device that are connected through the port. So I have connected this cable to the first port of switch and the other end to this particular device, that is PC0 computer. So now computer MAC address is recorded in the MAC table of this particular switch for the corresponding port, that is first Ethernet 01, and for doing so it will take 50 seconds. So you have observed that for 50 seconds the color of the LAN port, that is first port, first Ethernet 0, stays orange. After I have established the connection, the first Ethernet 0 port of this particular switch stay orange for 50 seconds until the MAC address was successfully registered in the MAC table of this particular switch. So after successful registration, the orange color turns to green. So I will repeat the same process for this PC1 computer and these two laptop 0 and laptop 1. You can observe. Now I will connect this PC1 LAN port first Ethernet 0, one end of the cable, and other end of the cable I will plug it to first Ethernet 02 port. You can see the first Ethernet 01 port is not available, that has been occupied by PC0, so that is not showing here. You can see the color is orange, as I have already discussed that it will stay for 50 seconds until the MAC address, or you can say the physical address of this particular device PC1 registered successfully to this MAC table of the router corresponding port which are connected with it, that is first Ethernet 02. I will repeat the process for these two laptop. You can check it out. I have connected all 4 end devices, 2 computers and 2 laptops with the switch, and as I have already told you, the color of those port are still orange. First Ethernet 03 and first Ethernet 04, those 2 port of the switch are still orange. It will take 50 seconds. Slowly it is turning to green until and unless those devices, those laptops physical address, or you can say MAC address, getting registered in the MAC table of the switch for the corresponding port to which it is connected with. So now we can say the MAC table has been registered successfully in this particular switch. Okay, now I will try to send a packet from laptop 0 to PC1. So at your right you have this option, these tools. So this is the message tool. I will click this tool. So I have taken a message. You can see this is the message icon. I will try to send this message from this particular laptop to this PC. This PC will be the receiver. Let me check. Will this particular PC able to receive the message that the laptop 0 will send or not? You can check it out. PC1 has no functional port. That means PC1 was unable to receive the message, that message which was sent by laptop 0. Why? Because I have not assigned the IP address to any of these devices. So now I have to assign the IP address. So you can see my cursor holds the message icon. So I have to release this selected message icon from my cursor. To do that, I will press the escape button on my keyboard. So after pressing the escape button, I have successfully released the message icon from my cursor. So I will be now assign the IP address in these 2 computers and 2 laptops. As I have already discussed in the theory that IP addresses are the unique recognition for any networking devices to communicate data packet in a particular network. So without having the unique IP addresses, it is not going to possible for sending any data packet in a network. So let me assign the IP address first. So I will assign the IP address in this particular PC, that is PC0. So I have selected the PC0. So I have opened the PC0 option. You can see this particular menu, custom interface, desktop, config, physical. I will go to desktop. Under desktop there is IP configuration tab. I will use this tab. So we have the option to provide IP address. So I will use a static option. So static option is selected by default. Now I will provide the IP address. So let me use class B IP address. So we know, we have discussed in the theory portion that class B IP address, the first field will lies between the range of 128 to 191. So I have to give a value in the first field. The value must lies between 128 to 191. So let me provide 130. So in the first place I will provide the value 130. So 130 lies between 128 and 191. So that signifies that this IP address will belong to class B category. So I will give the IP address as 130.0.0.1. So I have assigned the IP address of the particular computer, that is PC0, as 130.0.0.1. So we can observe clearly that 130.0.0.1, there are 4 fields which are separated by dot, and the first 2 fields, that is 130.0, this is the network address, and the later part of this IP address, this 2 particular field, that is 0.1, this is host address. We know that IP address size is 32 bit for IPv4. So we are presenting IPv4. So in this 32 bit IP address for class B category, first to space that is occupied by the network. So the address of the network for this particular IP address is 130.0. This is a 16-bit IP address. We know that each field holds the space of 8 bits. So there are 8 bits for each field. There are 4 fields, so that is 8 into 4, 32. So this is 32-bit IP address. As because network hold 2 fields for class B IP address, so 8 into 2, that is 16-bit space occupied for network, and the later part, that is 0.1, this particular 16-bit space is held by the host, and the default subnet mask for class B IP address is 255.255.0.0. So the default subnet mask for class B category IP address will be always 255.255.0.0, and class B category is a 16-bit IP address. Why 16-bit IP address? Because the value of network hold the address space of 16-bit. So these 2 particular field are the space hold for addressing the network. That is why each bit is 8 byte. So each field is 8 bytes. So 2 fields has been occupied by the network. That is why 8 into 2, this is 16-bit IP address. Okay, now I will provide IP address to PC1 130.0.0.2. I have been maintaining the sequence for PC0. I have set the IP address that is PC 130.0.0.1, and for this particular PC I have assigned the IP address 130.0.0.2. so I have been maintaining the sequence. Desktop IP configuration 130.0.0.3, default subnet mask we know 255.255.0.0, and for this 130.0.0.4 130.0.0.4. okay, so I have assigned IP address in this port system. I will use this note to remember the IP address which I have assigned to this particular PC. I will write down here 130.0.0.1. so IP address for PC0 130.0.0.2, IP address for PC2 130.0.0.3, IP address for PC3 130.0.0.4, IP address for PC4. so you can check it out to remember that what IP address we have assigned over this network. I have used this particular tool, that is place note, to write down here under this end devices. So now I will check by sending packet. So I have already assigned the IP address. I will check by sending packets that the connection is live and I can able to send packet or not. So I have taken a packet from here. This packet you can check in my cursor has selected a message that I would like to send from laptop 1 to PC0. okay, you can see the status over here, successful. So I have successfully able to send the packet from laptop 1 to PC0. You can see the source from where I have sent a packet. The source was laptop 1 and the destination the receiver who have received the packet. So PC0 was the destination. PC0 has successfully received the packet which I have passed out. So the transaction was successful. Let me check by sending another packet from laptop 0 to PC1. We can see successful. So now I will check by pin test. So I will select PC0. So I have select PC0. I will open the command prompt of PC0. So from PC0 computer I will go on the desktop tab and I will select the command prompt application. So CMD application already appeared in front of me. I will check the connectivity from PC0. I will check whether this PC0 can connect all other 3 systems in this particular network or not. So for doing so, what I need to do, it is required to use the ping command, so pin command, followed by the IP address of the respective system which I would like to access from the network. So I will write ping space. I will check the connectivity of PC1 from my system. So I will type the IP address. So IP address of PC1 is 130.0.0.2. we can see. So this is the IP address of PC1. I am checking whether my system, I am using this system, I have opened this particular system. So from here I am checking whether I can connect and I can access this particular system or not. So I am doing that by using IP address, pin IP address. So I will press enter to check. You can see reply from that particular PC, 130.0.0.2 bytes 32 times 0 millisecond TTL 128. You can see 4 packets sent and 4 packets received and lost 0%. That means I have successfully established the connection and I can access the particular system by the IP address, and 4 packets that I have passed from my system to PC1, and PC1 had received all those packets successfully without failing a single one. So now I will check the connectivity of laptop 0 by the same process, by typing pin, that is the command is required to be used to check the connectivity, and ping, that will be followed by the IP address. So the IP address of laptop 0 is 130 and .0.0.3. I will press enter. You can watch very clearly 4 packet was sent from PC 0, and that 4 packet was successfully received by laptop 0. You can see reply from 130.0.0.3 bytes 32. So packet size that was sent was 32, and time estimated time to perform this transaction was 0 millisecond, less than 1 second. So time travel limit that was 128. Packet sent 4, packet received 4, lost 0%. Now I will check the last computer, that is laptop 1, by pinning the IP address 130.0.0.4. so we can observe that last machine was to connected and accessed from my system. My system had sent 4 packet, and those 4 packet was received by laptop 1 successfully. So we don't have any failure to in this particular transition during the period of execution. So let me check IP address which is not registered in this particular network. ping space 130.0.0.5. so this particular IP address has no existence in this network. We have not assigned this particular IP address to any device. So in this network we just have 4 devices. We don't have more than 4 devices, and this particular IP address 130.0.0.5 had not been assigned to any particular devices. So I would like to check whether this particular command able to sort out this particular IP or not. Let me check. I have pressed enter. Now the pin command is searching that particular IP. So after searching for a time period, it has shown requested timeout. Why? Because that particular IP has no existence in this network. So there are a predefined period of time that will be used to search a computer in a network. Pin command can't search lifelong to any device. So there are certain criteria. There are a particular period of time. So during that period of time, the pin command will search the device by the IP address, and after expiry of the session, if the command fail to search the intended IP address, then it will show the message requested timeout. That means the time has been expired. The searching time of that intended IP address expired. So the requested time, and during that process we don't have any reply from that device. but time has been expired. Time which was assigned to find that particular IP address has been expired, and during that time the command has not able to find that intended IP address. So that means we can watch out here. We don't have asked for a device which has existence in this particular network. A fake IP address we have provided, but the pin command failed to find that fake IP address because that fake IP address has no exist. So that is why you have received a message of requested time out. Now I will do another thing. I will change the IP address of this particular laptop. So as I have discussed that these two portion belongs to the host network. Now I will change the network address. Till now all those 4 computers are belonging to same network address. You can watch out the network address, that is 130.0. the network address is 130.0. so I will change the network address to 130.1. so the network address for this particular laptop is now 130.1, and I will also change the network address for this particular laptop, that is laptop 130.1. These two laptop are in separate network. All those 4 devices are connected to a single switch, but these two laptop are in a separate network. The network address is 130.1, and these 2 computers are in another network, that is 130.0. Now the thing to observe, that is whether I can send a packet from this particular laptop to this particular computer. Previously I have tested out, before I have changed the IP address, we had successfully sent packet among all the system, but after changing the network address, we will observe whether we can send packet among different network or not. I would like to send this packet from laptop 0 to PC 1. Check here, in progress and failed. So I could not able to send the packet from laptop 0 to PC 1 because we have changed the network, but I can easily send packet from laptop 1 to laptop 0 because these two devices are in same network, that is 130.1. the network address is 130.1. so we can send packet among these two devices, and we can send packet between these two devices. We can see successfully transaction, but it will never possible to send packet among these two separate network. Check, I'm trying to send a packet from laptop 1 to PC 0, in progress and failed. So it will never be possible to send packet among separate network. To send packet in a network connected by switch, we have to keep the address, that is network address, same in all the networking devices. So now I will create another connection of another 4 computers. So let me take a switch, another switch I will place it here. I will take to computer, to laptop, again to establish connection here, another connection I will establish, and I will connect all those computer together. I will repeat the process, same process. I will repeat the same process as I have done to create the first connection. You can observe the color is still orange because the MAC address is being registered to the MAC table of the switch. It will take 50 seconds to complete the process. I will set the IP address now under desktop configuration 130.0.0.5 130.0.0.5. I will provide IP address here 130.0.0.6. I will provide IP address 130.0.0.1.0.7 130.1.0.8. Let me write down the IP over here 130.0.0.5 130.0.0.6 130.0.0. Sorry, this is 1.0.7 130.1.0.8. so I have assigned the IP addresses in these four networking devices, and I have also using this note I have written the IP address to remember those. Okay, so let me check the connection. I have sent packet successfully from PC2 to PC3 of this particular network successfully. I will try the same to send a packet from laptop 3 to laptop 2. Successful. Now I will try to send the packet from this PC3 to laptop 3. In progress and fail. Why? Because you can check it out. You can see 130.0, 130.1. so network address of these two particular networking devices are different from these two devices. We can see the network address is 130.1 and the network address of this particular laptop is 130.1, whereas the network addresses of these two computers are 130.0, 130.0. so it will never possible to send packet among separate network using switch. I will connect these two switches through crosswire. Why I will take crosswire? Previously to connect computers and switch I was using straight cable. Why? Because computers and switches were different kind of devices. To connect different kind of devices we have to use straight cable, as because I will connect both the switch, so both the switch are under same category of device. To connect same type of device we have to use crosswire. So to connect similar kind of devices we will be using crosswire. So I have taken a cross cable, I will connect it so we can see the available number of ports, any available number. So I will not break the sequence. So I have connected. You can see the color stays orange. Why? Each MAC table will record the registered computer of each other switches. So you can see this number of MAC addresses of these computers will be registered here in this particular MAC table. The MAC table of this particular switch for the corresponding port that I have connected with will register all the MAC address I have connected through it, and this particular port and the MAC table of this switch corresponding of this particular port, that is first Ethernet 06, will record all the MAC addresses of this network. So this will take 50 seconds. So now I have successfully registered the MAC addresses. Let me check whether I can send the packet or not. I will take a packet that I will try to send from PC0 to PC3 of this network. Successful. So actually the network address is same, but physical connection I have established with two separate switch. So it will be possible to transfer or send packet. See, from PC1 of this setup I will send a packet to here. Successfully the receiver received the packet. So PC3 were the receiver. You can check it out. The transaction was successful. Now I will check out the transaction in these two particular network. See, successful. Laptop 1 to laptop 2. Yes, but let me try it to send the packet from here, from this setup PC1 to laptop 3 here. In progress and failed. Why? Because the address of PC1 was 130.0.0.2, and so the network address was 130.0. This was the sender and this was the receiver. The address was 130.1, so a different network. This system belonged to a different network, so it will never be possible to send packet from here to here because both were in different networks. So we can't send packet where the network address are separated from one and another. So physically we have connected two separate setup. Two switches are connected and we have seen that quite successfully we have sent packet among these two separate switches, these two separate setup, but under the condition that the network address was same. Using first I will delete this IP address. Okay, now I will connect and repeat the process of connection. So I have connected. Now I will assign the IP address. Let me check whether the system, whether the setup allow me to assign the same IP address that I have already assigned to this particular system. Let me wait until this particular port, that is first Ethernet 05, turns to green. So let me allow to register this particular physical address in this MAC table. So it is successfully completed the process of MAC registration. Now I will provide the IP address, same IP address that I have already assigned to this PC. Let me check whether the system allow me to do so or not. 130.0.0.1. See, this address is already used in this network. So now the system, while I was trying to allot the IP address, system had not allowed me to configure same IP address which I already had assigned it. Okay, in this class we have understood certain things. In next class we will learn the DHCP, how to configure a DHCP LAN setup.